Hey guys, welcome back to another competition video. Today we will be another question here. This is from the COMC 2009 contest. This is the 8th and final question of part A. And let's determine all, so as always, let's first read the question. So, determine all triples ABC of positive integers such that a factorial is going to be equal to 4 times b factorial plus 10 times c factorial, where n factorial is just going to be all of the numbers smaller than n, with n included, multiplied together. So example, 5 factorial will just be 5 times 4 times 3 times 2 times 1. Now, how are you going to solve this problem? Well, let's do some casework here. Let's say, for our first case, b is going to be equal to c. And along with this, we can see that for all these cases here, a is obviously going to be bigger than b, and also a is also going to be bigger than c. If you're wondering why, it's because a is going to be equal to 4, a factorial is going to be equal to 4 times b factorial plus 10 times c factorial. So for 10, it's 10 times smaller, and you need to add 4 factorial b for it to be equal to a, and vice versa with b. So we know that these two are valid. A is going to be bigger than b, and a is going to be bigger than c. So going back to a casework here, let's say b is going to be equal to c. Now, since we have b is equal to c, let's just plug this into here with an equation. Let's get rid of c and replace it with b. We receive a factorial is going to be equal to 14 times b factorial. And this means that a factorial is going to have to be equal to 14 factorial, and that b factorial is going to have to be equal to 13 factorial. Now, why is this? Well, because if you look at here really quickly, what is 14 times 13 factorial? Well, it's actually just 14 factorial. Why is that? Well, because 13 factorial is 13 times 12 times 11 times 10, all the way down to 1. And 14 factorial is the same, but you start by giving an extra 14. So once we have this multiple up here in the front, we know that now 13 factorial times 14 is going to be the same thing as 14 factorial. And so this means that a has to be 14 and b has to be 13. So this means that our triple here is going to be, so a, b, c is going to be equal to, here we have 14, 13, and 13, as b and c are equal to each other in this case. Now let's look at another case. So these cases are going to be whether or not b is going to be bigger than c or b is going to be smaller than c. So let's do b is bigger than c first. Now here, let's divide a factorial up here by b. So here we get a factorial divided by b factorial, which is going to be equal to 4 plus 10 factorial 10 times c factorial divided by b factorial. Now here we can split this into another two cases, where the first one is that b is going to be equal to 10, and the second one is going to be that b is going to be equal to 5. This is because we can see here that b factorial is probably going to have to be a factor of 10, right? So it would have to be equal to 10 over 5, and this is because we need this to be an integer. So obviously we need b to be equal to 10 factorial or 5 factorial to get rid of this 10 here. And this means that if b is equal to 10, we know that c here is going to have to be equal to 9. As I said before, this is because 9 factorial times 10 is going to be 10 factorial. So 10 factorial divided by 10 factorial is 1, and that's an integer, and we need that. Same thing with b is equal to 5, it would just be c equals to 4. Because now on top here, it would actually be, on the bottom we have 5 factorial, and on top we actually have 2 times 5 factorial. Because you can split the 10 into 2 and 5, and use that 5, multiply it by 4 factorial to get 5 factorial. So both of these cases are allowed, and then we can solve for a. However, there's a problem here. Let's look over here. We will receive that a factorial divided by b factorial is going to be equal to 5. And this is kind of a problem here, because this means that a factorial is going to have to be equal to 5b factorial, which would probably mean that, well, this is actually going to be impossible, because we can't actually solve this. So this is impossible. We don't need this. We can't solve for this without breaking one of our conditions. But if c is equal to 4, this will actually be solvable. So same thing from before, a factorial divided by b factorial is going to be equal to 6, however, in this case. And now we just have a is going to be equal to 6. As a factorial here will be equal to 6 if you use cross multiply, and so a is going to be equal to 6 here. So here in the triplet is going to be a, b, c is going to be equal to 6, 5, and 4. Now, let's look at our final one, our final condition, our final case way, which is, what if C is going to be bigger than B? So the opposite of number 2. Now here it's actually going to be the same exact thing, but with C instead. So it would be a to the factorial divided by c to the factorial is going to be equal to 10 plus 4 times b factorial divided by c factorial. Same thing before with the case way. We can see that we have two cases here. If c is equal to 4 and b is equal to 3, or if c is equal to 2 and b is equal to 1. So I'll just write those out. And now that we have this, we can solve for a to the factorial. So on top here, we can see that a to the factorial would have to be equal to 11c by plugging these numbers in. And that's also a really big problem here. As we said before, we know that c is equal to 4. Plugging it into here, we know that there's no factorial equal to 11 times 4 factorial. That doesn't exist. There's not a factorial like that. And so this means that this is impossible. It does not exist. So a is not a solution. We don't have a solution for a here. But going back to this bottom one, we see here that a factorial is going to be 12 times c factorial, right? And this is just equal to 24, since we know that c is equal to 2 in this case, and this is equal to 4 factorial. So in here, we factor out 12 into 3 and 4, 3 times 4 times 2 factorial here, because in this case, c is equal to 2. That's still going to be factorial, so we know here that a is equal to 4. This means that we can solve for a here, and we give another triplet, which is 4, 1, and 2. This means for each of these cases, we have exactly one triplet that works. So our 3 triplets here are going to be 4, 1, and 2, 6, 5, and 4, and 14, 13, and 13. So our answer is going to be 14, 13, 13, 6, 5, 4, and finally 4, 1, and 2. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.